the Big Bang is not the beginning of the universe. This is one of the most common misconceptions about how physics actually works. And yes, I got this wrong too, and I'm a physicist. This is not about wording or mathematical stuff. This is a crucial point about scientific theories that most people never heard of. But you'll hear it here, after a short and simple summary of the Big Bang theory. And afterwards, we'll find out what the Big Bang actually is. I thought I knew how the universe began with the Big Bang. And I bet that if I randomly asked other physicists, most would give me the same answer. Of course, I mean, the Big Bang theory is a great and most importantly proven theory. But this is where we must make a distinction. We need to distinguish between the Big Bang and the Big Bang theory. The Big Bang theory is amazing. It's a remarkable theory about the evolution of the observable universe. And it's been confirmed many times. So we know a lot about the Big Bang theory, but we know almost nothing about the Big Bang. But I'm jumping ahead of myself. First, the Big Bang theory, also called Big Bang model. The Big Bang theory wants to describe how our universe evolved. It says that roughly 14 billion years ago, our universe started out extremely tiny. Not because it was small in itself, but because there was hardly any room. Space just was not there yet. So the universe was densely packed and therefore extremely hot. But luckily, space immediately started to expand and the matter in it started to cool down. How do we know that? Well, if we want to know how our universe started out, we should look at our current theory about the universe and use it to go backwards in time. So, let's look at general relativity. When Einstein published general relativity, he wanted the universe to be static, meaning neither expanding nor contracting. But that didn't turn out well, because then the universe wouldn't be stable. Sorry Einstein, but you can't always be the winner in science story time. Alright, then Alexander Friedmann showed that general relativity naturally leads to an either expanding or contracting universe. Georges Lemaitre first proposed that the universe is expanding and therefore started from what he called a primeval atom. That was the first Big Bang concept. Edwin Hubble confirmed that the universe is indeed expanding. George Gamow and Ralph Alpher were proposing that the universe started off extremely hot and dense. While looking them up, working on this video, I got hit by a brilliant joke. How come I haven't stumbled upon this before? On one of their papers you'll find a third author, such that they became Alpha, Beta, Gamma. That sounds like Alpha, Beta, Gamma, the first 3 letters of the Greek alphabet. Well, that's what I call peak physicist humor. I mean, we often use Greek letters, and that's the beginning of the Greek alphabet. Perfect for a paper about the beginning of the universe. Okay, now that I've explained it, it's not that funny. No, it's still funny, it's hilarious. Importantly, the scientific community finalized and also verified the Big Bang theory. The theory you get when you trace general relativity backwards in time. The theory that the early universe was hot, dense and opaque. That's why we can literally not directly see what happened there. But the light from when the universe first became transparent still reaches us today as cosmic microwave background. That was only after 380,000 years, and stars and galaxies took several 100 million years to form. Okay, and what sits at the beginning of the Big Bang theory? At the beginning of the evolution of our universe? The Big Bang, you might say. So the Big Bang is the beginning of a universe, you might say, and this was just clickbait, you might say. Or at least that's what I would have thought. But let's take a step back. Let's go over how theories in physics actually work. Physicists have not found the ultimate theory of everything and anything yet. This means our current theories, our current descriptions of reality are limited. Newton's gravity, for example, works well in a lot of cases, but fails if the things we're talking about are getting too heavy or too fast, whereby fast means close to the speed of light. Maybe you've already heard that light bends around massive things like stars or galaxies. That's called gravitational lensing. Newton's theory does not predict that, because Newton's theory explains gravity with masses and light has no mass, so its path should not bend. Newton's theory is not applicable here, but Einstein's theory does indeed predict that. General relativity explains gravity with the curvature of space-time, and light follows the curvature of space-time, just like everything else. So, different theories, different domains of applicability. However, Einstein's theory has its limits too. Its domain of applicability is not everything and anything. General relativity fails exactly here. General relativity predicts the Big Bang as a moment in time, as the moment when space and time started to exist. By the way, not as it is often shown like an explosion. Nothing can burst into space if space doesn't exist, but more like a smoothly distributed matter suddenly there, all at once. General relativity predicts the Big Bang as a singularity where density is infinitely big. Basically, as soon as we look at time zero, we end up dividing by zero. That makes some terms blow up to infinity, and that's what we call a singularity. But you don't need to know what a singularity is. What matters is that we think relativity fails exactly at such singularities. So the Big Bang is a prediction of general relativity, but beyond its limits, outside of its domain of applicability. Newton's gravity predicts that light does not bend, but that prediction is beyond its limits. So it's not really helpful, and we know that it's wrong. In the same way, this prediction of general relativity is more or less useless, and probably wrong. You must somehow include quantum mechanics for such conditions. So the Big Bang is not the beginning of the universe. It's the ending of our current understanding of the evolution of the universe. The Big Bang is the current limit of what we know, or rather the current limit of what we don't know, because we don't know what happened before the Big Bang. We don't know what happened during the Big Bang, but we do know what happened right after the Big Bang. So, the Big Bang is not the beginning of the universe. It's also not the singularity at the beginning of the universe. It's the name for the moment from which we no longer have any clue. It's the beginning of our uncertainty. If you are less uncertain now, please leave me a like and subscribe. Have a great day and thanks for watching.